Welcome back to General Chemistry on Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to do a second example of drawing a Lewis structure, given the same steps that we talked about in the previous video. And what we're going to see in this case is after we do this fourth step where we add all the non-bonding electrons or lone pairs around the peripheral atoms, we're going to have some electrons left over to add. And I'll show you what we're going to do with those electrons as we go through the video. But we're going to initially follow the same steps that I outlined in the previous video. So our compound in this example is selenium tribromide, SeBr3. And the first thing we want to do is count the total number of valence electrons in this compound. And again, the way I say to set it up initially for beginners is like a math problem such as this. Eventually you can move away from this once you get more proficient at it. But notice I have one selenium atom and 3 bromines. So let's figure out how many valence electrons there are per selenium. Okay, well, remember we just look at the column number. Here's column 1, 2. We skip the transition metals and go 3, 4, 5, 6, 7, 8. Okay? Selenium is in column 6 or group 6, so selenium will have 6 valence electrons. So 6 valence electrons. Each bromine atom will have 7 because bromine is actually in group 7, and so each bromine atom will carry 7 valence electrons. So now I can add this up. 6 valence electrons, 1 times 6 from the selenium. 21 valence electrons from the bromine because of 3 times 7. So 6 plus 21, that's going to give me a total valence electron count of 27 electrons. Okay, 27 valence electrons. So let's remember that. Now we'll determine the central atom. And as we talked about in the previous video, the central atom is typically the minority atom. So I've got 3 bromines and 1 selenium. So that probably means the selenium is the central atom, always a good bet. So we're going to draw the selenium right there in the center. And then I'm going to next place all the peripheral atoms around the central atom bound by single bonds. So I'm going to put the 3 bromines around the selenium like this and connect them by single bonds. All right. Again, remember each of these single bonds represent shared bonding electrons, and each bond is going to be 2 electrons, 1 donated by the bromine, 1 donated by the selenium, so 2 per bond. That gives me a total of 6. So in other words, I've used up now 6 valence electrons of these 27. Okay? The next step is to add lone pairs or non-bonding electrons potentially up to the total while not exceeding any atom's octet. Again, we're going to add them around each of these bromines, but we don't want to exceed the octet of each of these bromines. Okay, so I'm going to add 1, 2, 3, 4, 5, 6 around each bromine atom. The reason I don't add any more than that is because each of these non-bonding electrons, there's 6 of them, but I have to count the 2 electrons from this bond. Okay, so each bromine is technically going to be having 8 valence electrons. 6 from the non-bonding, 2 from the bonding. Okay, 2 from the bond in other words. Okay, so that means I'm going to be adding 3 lone pairs or 6 non-bonding electrons around each of these bromine atoms. Okay, so let's kind of count this as we go around. I've already used up 6 of these valence electrons, and I'm trying to get to 27. So 6, start up here. 7, 8, 9, 10, 11, 12. Okay, let's go on to the one down here. 13, 14, 15, 16, 17, 18. All right? And then 19, 20, 21, 22, 23, 24. Okay? That count has now accounted for all 3 of the bonds. So that was 6. And then the 18 of these that were non-bonding. And I counted up to 24. Okay? Now, we've got a problem, because I've already exhausted all of these steps. I've added all these non-bonding electrons, okay, around all the bromines, and I've counted for all my bonds, so 6 electrons there, but I'm not at 27 yet. I'm only at 24. That means I have 3 valence electrons remaining. So what to do with those? Well, the general rule of thumb is you just put them on the central atom. Okay, so I've got to put 3 electrons now on this central atom, okay? And so I've got 1, 2, 3, and if I count that from 24, 25, 26, 27. Now I'm at my total valence electron count, and so now removing all these numbers here, this is what my final Lewis structure will look like. All the bromines are going to have 3 lone pairs on them, and it turns out the selenium, the central atom, will actually have 1 lone pair and then 1 what we call a lone electron. This lone electron is not termed a lone pair since it's actually by itself. It's not a pair at all. It's actually what we call a radical. It's actually a lone electron, but some people will call that a radical. That's a topic for another video, but just a little piece of information there. But this is how you go about drawing these Lewis structures. So you follow all these steps. They're basically the same for pretty much any problem you should encounter in a general chemistry course, like we did in the previous video. But if you have any electrons remaining that you haven't added after you count up all the non-bondings that you've added around the peripheral atoms, then you're forced to usually add them onto the central atom. And you won't always have a lone electron. Sometimes it will be an even number that you'll have to add, but generally you'll put that on the central atom. Okay? So hopefully this makes sense, and we're going to do another example of this in the next video. What we'll actually do in that video is see an example where we actually have 4 bonds around a central atom. So make sure to join us then. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you.